Hello everyone, we have already discussed the concept of lattices. So a poset is a lattice if it is both meet semilattice and joint semilattice. Then we have discussed bounded lattice. Bounded lattice is a finite lattice which have upper bound and lower bound. Then a distributive lattice is a lattice in which every element has at most one complement. So every element has 0 or 1 complement. Then a complemented lattice is a lattice in which every element should have a complement and complement can be more than one. So a Boolean algebra B is a bounded, distributive and complemented lattice. So that's why a Boolean algebra is a lattice in which every element has exactly one complement. So let's check for this lattice A, B, C, D. So D is the upper bound, A is the lower bound, and A and D are complements of each other. Then B and C are complements of each other because B joins C is D and B meet C is A. So this is a Boolean algebra B because in this lattice every element has exactly one complement. Then we have A, B, C, D, E, F lattice. Then here A and F are complements of each other and E and C are complements of each other, but B and D does not have any complement. So if we check for pair BD, then B join D is D and B meet D is B. So B and D does not have any complement. So this is a distributive lattice as every element has at most one complement. So this is distributive lattice only. Then let's check for this lattice ABCD. So A and D are complements of each other, but B and C does not have any complements. So this is also a distributive lattice according to the definition. It is not a Boolean algebra. Then A and B, it's a Boolean algebra because it's a bounded, distributive and complemented lattice. A and B are complements of each other. Then we have A, B, C, D, E. Then P and E are complements of each other. Then let's check for pair AD. So A join D is B, but A meet D is C. Then let's check for pair AC. Then A join C is A. Then A meet C is C. So this pair is also not complement of each other. So that's why it is a distributive lattice because A, C and D does not have any complement. Then here this is a lattice and here A and F are complements of each other. Then E has the complement D and C, B has the complement D and C, and D has the complement E, B, then C has the complement P and E. So these four elements have two complements each. So this is a complemented lattice, but not a Boolean algebra. Then here E and B are complements of each other. Then A and F are complements of each other. But C and D does not have any complement. So that's why this is a distributive lattice, not a Boolean algebra.